When we think about storms in space, it's easy to picture the sheer scale of Jupiter's Great Red Spot, a massive storm that's been raging for centuries, large enough to engulf Earth several times over. But we sometimes forget that hurricanes, which are just as powerful and destructive, can happen right here on our own planet. Today we're looking at Hurricane Milton, a Category 5 hurricane that formed suddenly in the Gulf of Mexico and caused a lot of damage in Florida. NASA satellites and astronauts aboard the International Space Station captured some of the most impressive images of the storm, showing us just how huge it was from space. It's a stark reminder of the forces we face here on Earth. Hurricane Milton came out of nowhere. It first showed up as a tropical storm on October 5th over the warm waters of the Gulf of Mexico. At first, it didn't seem like much of a threat, with wind speeds barely reaching 28 kilometers per hour. But in just 2 days, Milton had intensified dramatically, rapidly evolving into a catastrophic Category 5 hurricane with wind speeds exceeding 280 kilometers per hour. The sea temperatures in the Gulf were unusually high, making this sudden intensification possible. In fact, they're among the warmest on record. With sea surface temperatures above 30 degrees Celsius in some areas, the conditions were ideal for the storm to grow rapidly. Warm water is basically what fuels hurricanes. When the ocean is warmer than usual, these storms can quickly become huge forces of nature. Hurricane Milton is a great example of how quickly a storm can intensify when the conditions are just right. But what exactly is it that makes hurricanes like Milton so dangerous? To get a handle on that, we need to look at how hurricanes are formed. In a nutshell, hurricanes are huge heat transfer engines, taking heat from the ocean and releasing it into the atmosphere. These storms usually form in tropical areas where the water temperature is at least 26.5 degrees Celsius. Warm, moist air from the ocean rises, which creates a low-pressure area at the surface. This causes more air to flow in, which also warms and rises, creating towering thunderclouds. As the warm air keeps rising, it cools and condenses, releasing even more heat. This heat warms the air around it, making it rise even faster. This cycle keeps going, drawing more and more energy from the ocean. Before long, a powerful storm system starts to take shape. The key to a hurricane's growth is its rotation. As the Earth rotates, it gives the storm system a spin, making it rotate. This is the Coriolis effect, which gives the storm its spiral shape. As the winds speed up, they wrap tightly around the center of the storm, forming a structure called the eye. When a storm's sustained wind speeds exceed 119 kilometers per hour, it's classified as a hurricane. As long as there's a steady supply of warm, moist air from the ocean, hurricanes can keep on growing. Once a hurricane makes landfall, it loses its power source. Once the storm loses its warm ocean source of energy, it starts to weaken, but it can still cause a lot of damage before it dissipates. The timing of Hurricane Milton was especially bad for those living in Florida. As they were getting back on their feet after Hurricane Helene, Milton struck the Sunshine State. In just a few days, Milton went from a tropical storm to one of the most powerful hurricanes ever recorded in the region. As it headed towards the Florida coast, the National Hurricane Center and NASA were keeping a close eye on it. One of the main reasons Milton intensified so quickly was because there was very little wind shear in the atmosphere at the time. Wind shear basically means changes in wind speed and direction with altitude. In many cases, high wind shear can weaken or even disrupt a hurricane by tilting its structure, causing the storm to lose energy. However, when the atmosphere has low wind shear, as was the case with Milton, the storm is able to grow unchecked. In a low shear environment, the storm remains vertically aligned, which allows it to efficiently draw energy from the ocean and strengthen at an alarming rate. NASA's satellites were key in tracking Milton's rapid development. The data they collected, along with measurements from NOAA's Hurricane Hunter aircraft, gave us a clear picture of how the storm developed. NASA's monitoring of sea surface temperatures was especially useful in understanding why the storm intensified so quickly. The agency's cutting-edge remote sensing tech also let scientists see changes in the storm's structure, including the formation of a new eye wall. An eye wall replacement cycle is when a new ring of thunderstorms forms around the old eye wall and eventually replaces it. This can temporarily weaken the storm, but once the new eye wall is fully developed, the hurricane can re-strengthen, sometimes becoming even more powerful than before. Milton went through an eye wall replacement cycle just before making landfall, which caused its winds to decrease slightly. However, the storm remained a formidable Category 5 hurricane as it approached the Florida coast. NASA's images of Hurricane Milton from space are pretty incredible. The images, captured from the International Space Station, showcase the storm's immense scale and distinct eye. From space, hurricanes look almost serene, with their spiral bands of clouds stretching for hundreds of kilometers in every direction. As we're all too aware, the view from the ground is a very different story. These storms bring ferocious winds, torrential rain, and storm surges that can inundate entire cities. As Milton headed for Florida, people were bracing for the worst, boarding up windows, evacuating coastal areas, and getting ready for the impact. When Milton made landfall near Siesta Key, it was blowing at over 280 kilometers per hour. The storm surge flooded coastal communities, damaging homes, businesses, and roads. In some places, the surge reached over 15 feet high, sweeping away whole neighborhoods in just a few hours. NASA's disaster response teams worked closely with local authorities to provide real-time data on flooding, power outages, and rainfall levels. Their disaster response coordination system was really helpful in managing the crisis on the ground, supplying high-resolution satellite images and detailed maps to assist emergency services. While saving lives was the main priority at the time, the focus has now shifted to rebuilding and recovery. The quick intensification of hurricanes in Milton is making us think about how climate change affects their formation. As global temperatures rise, so do sea surface temperatures. As oceans get warmer, they can provide more energy for storms, which can lead to more frequent and intense hurricanes. While it's not possible to attribute any single storm to climate change, the overall trend is clear. We're seeing more powerful storms than we did in the past. Scientists are still looking into the link between climate change and hurricane activity, but it seems that we may be heading towards an era of more frequent and severe storms. NASA's role in monitoring and studying hurricanes is more than just providing images and data. The agency is also playing an active role in research aimed at improving our understanding of these storms and how they evolve. Thanks to satellites like GOES-16 and GOES-17, which are run by NOAA in partnership with NASA, scientists can now capture high-resolution images of hurricanes in near real time. These satellites provide crucial data on everything from sea surface temperatures to atmospheric moisture levels, helping forecasters make more accurate predictions about a storm's path and intensity. Additionally, NASA's Airborne Science Program is a major player in hurricane research. Aircraft equipped with specialized instruments fly directly into storms, collecting data on wind speeds, pressure, and temperature. This information is vital for improving the models used to predict how hurricanes will develop. As Hurricane Milton moved inland, it started to lose strength, but not before leaving a trail of destruction in its wake. The storm knocked out power lines, ripped roofs off buildings, and uprooted trees. In the days after the storm, rescue and recovery efforts were underway as emergency teams worked to restore power, clear debris, and provide aid to those affected. It'll take a while for Florida to recover, but NASA and other agencies are already helping with the rebuilding process. Hurricane Milton is a stark reminder of the power of nature and the importance of preparation and technology in the face of such storms. NASA plays a big part in monitoring and studying hurricanes. This is important for understanding how these storms form and evolve, as well as for providing the tools and data needed to protect lives and property. As climate change continues to impact our planet, the work being done by NASA and other scientific agencies will become even more important in helping us understand and respond to the challenges ahead.